It's time now for the rational zero theorem. This will really open up the type of polynomials we can work with. I'm going to go ahead and just paste the theorem in here for us to talk about, and then we'll use it together to clarify what it says. Whew. All right, here is the theorem. So it's a little wordy. The rational zero theorem says if the polynomial looks like this nice situation here, and it has integer coefficients, then every rational zero of the function has the form p over q. And we're going to talk a lot about p over q. So p over q, where p is a factor of this term at the end of the polynomial function. Basically, it's going to be a factor of the constant term. And then q is going to be a factor of the coefficient on your highest agreed term. Basically, it's got to be a factor of your leading coefficient. So it's kind of a mouthful, but what it does is, let's say we're given a polynomial function, we have no idea how to factor it. We can begin taking guesses at the zeros using the rational zero theorem. So let's go ahead and just dive into an example. I don't expect this beautiful theorem here to make perfect sense until we try some examples together. So let's go ahead and give ourselves a problem to start with. Let's say that we were asked to list out, this time let's just list out all possible rational zeros. So as I'm writing the word rational, hopefully you're realizing that it means this theorem isn't going to help us with finding imaginary zeros or irrational zeros, but it's going to help us out with rational zeros. So let's say our function is 2x to the fourth minus 5x cubed plus x squared minus 4. Okay. So you may have noticed in that rational zero theorem, the way it was written, we really care about the values at the end and the beginning if your polynomial is in standard order. So I'm going to use the same color coding. I'm just going to circle this -4 at the end and this 2 at the beginning, and realize that the possible rational zeros will be dependent upon the factors of those values. So the possible zeros take on the form p over q, where p is going to be directly related to the factors of the constant term. So here's how we're going to think through this. P is tied to, in our case here, the factors of -4. So if I asked you to list out factors of -4, you would say, well, for sure, plus or minus 1 divide -4, plus or minus 4 divide -4, and then I think the only ones we're missing would be plus or minus 2. So we can just list out all the values that basically you could think about it going evenly to -4. So -4 divided by any of those 6 numbers I just wrote out would produce an integer result. So those are the factors of -4. Now q then must be tied to the other number we've circled, which in our case here is the coefficient on the x to the fourth term. So what are the factors of 2? It has less options than -4 did, so 2 has factors of plus or minus 1 or plus or minus 2. So what we've done is we've created a list of possible zeros. These are not all going to be zeros because, well, we can see that this polynomial only would have 4 zeros as it is. So let's see if we can clean up that list just a little bit. I think this looks a little funny, right? That would be the extensive list. But if I wanted to simplify it more, what I'm going to show is I could take the plus or minus 1, divide it by the plus or minus 1. I could also take the plus or minus 1 and divide it by the plus or minus 2. So I'm just starting to break up these factors. I could take the plus or minus 2, divide it by the plus or minus 1. I could take the plus or minus 2 again, but this time divide it by the plus or minus 2. Starts feeling a little lengthy. And just for thoroughness, let me go ahead and do that with the last option. I could take the plus or minus 4 and divide it with the plus or minus 1, or the plus or minus 4, divide it with the plus or minus 2. So there are going to be some duplicates as we simplify this list. We don't need to count duplicates more than once. So let's just continue simplifying. Plus or minus 1 divided by plus or minus 1 would be plus or minus 1. Plus or minus 1 divided by plus or minus 2 would be plus or minus a half. The next one would be plus or minus 2. So we've done first, second, and third. 2 over 2, this would simplify to one that we've already got in our list, right? We already got the 1, so I don't need to write it again. Then we get plus or minus 4 divided by plus or minus 1, which simplifies to plus or minus 4. And plus or minus 4 over plus or minus 2 simplifies to the 2 that we already have in our list, so no need to write that again. So what this means is the rational zeros theorem, I'll just clean this up a little bit, says for the polynomial function we were given, there are a total of 8 possible rational zeros, which are plus 1 or minus 1, plus 1/2 or minus 1/2, plus 2 or minus 2, plus 4 or minus 4. And for this example, I don't need us to narrow down which of those are the actual zeros, but these are the possible zeros. As the question asked for, we have listed the possible zeros for the given polynomial. So that's a little bit about how to use the rational zero theorem. We're going to want to use it in a more thorough way in the future, which is we actually want to find the specific zeros of a polynomial. We'll do that in the next video.